into. So with this acronym, right, like there's a mini tutorial on it on the main channel, but then like since we're here, we could maybe just briefly speak about it. Like when you always want to write this out when you start with the Euclidean geometry question, because the D reminds you of diameters, you see, because with the diameter, you will always then remember that, okay, fine, I have a theorem that says if I have a diameter, I should look out for an angle subtended by that diameter. You see, the R is for radius, because whenever you see the radius, you should remember that always be on the lookout for example, like an isosceles triangle. You see, because this is something that's easily missed in a sketch, things like an isosceles triangle. And then anytime you're also going to work with the radius, I mean, like you'll also have other theorems that deal with the radius, you see. Theorems that maybe a line from the center, if you have a radius that's going to touch a tangent. Well, we'll talk about this one when we get to the T. But then for radius, we should just remember things like this. And also the theorem that states that an angle at the center of a circle is double the angle at the circumference, you see. So you'll have this here. And then you'll have this here. Let's see, like that. Whoa, sure. Like that. So the moment you think of a radius, you should then remember that this line is equal to this line. So you should also remember this theorem where like this angle is double whatever this one is over there, you see. So that's what the radius will also remind you of. And then thirdly, you have a cyclic quad, you see. A cyclic quad is your theorems of cyclic quads. You have like three things of a cyclic quad, three main ideas. The first one is that an exterior angle of a cyclic quad is equal to the opposite interior one. Secondly, we know that with cyclic quads, right, you have the angles in the same segment theorem that you should also remember, you see, because even though this is like a zigzag effect, as long as the 4 points are touching the circle, then you automatically will need to keep in mind that this angle is equal to that one. And then you'll also need to keep in mind that this angle is equal to that one, you see.
Hello.
Now, yeah.
Levi, do you know that we don't see anything here, ne?
Whoa, no ways. You're joking.
Yeah, I can hear you just saying this angle is equal to this one and we don't see nothing.
Oh my goodness.
I thought you were just saying it out loud for us to hear. I did not even know that you were.
No, when you say this angle, I was like, what?
Yes.
You dude. I think it's only fair if I like almost like scrape everything, because I'm so used to just sharing the screen immediately that yeah, it is awkward. But anyways, what I was trying to say, I think we can start backwards then, so that with the T, right, the T here refers to tangents. You always want to look for tangents when you're going to be given a Euclidean geometry sketch, you see, because with tangents you have quite a lot of theorems that deal with tangents. You have the one that says an angle at the center. I mean, if you have a radius of a circle, it will always meet a tangent at an angle of 90 degrees. Secondly, we also know that you have the famous 10 chord theorem. That's like a blunt one, you see. There's this here, and then there's this there, and then there's this over there. So with all this being said, this angle here is going to be equal to that angle there, you see. And then another theorem of tangents that we could think of, I mean, like this one is also like usually neglected, is the one that says tangents from the same point will be equal in length, you see. So for example here, this length will be equal to, this line will be equal to that one, you see.
Yes.
And then now for the P here should remind us of parallel lines, you see, because the idea with parallel lines is that, I mean, as long as you have parallel lines, you should remember things like fun, you know. This is always something that's super neglected. So you should always remember things like fun, and then obviously the proportionality theorem, proportionality theorem, you see, where you're going to be dealing with like similar triangles, you see. And also, let me just draw this image here so that you can just remember the piece for proportionality theorem and like fun. So the C that we were talking about there is for cyclic quads. You see, with cyclic quads, you have three main pictures for cyclic quads. Let me remove this so that we have space. So for cyclic quads, you will have something as follows. You will sometimes have a circle. Anytime you see that the 4 points are touching the circle, it's automatically a cyclic quad. But then the idea is the laws of a cyclic quad will tell you that if you have 4 sides, 4 points touching a circle, right? The exterior angle here is equal to the opposite interior angle over there. Like that, you see? And then you also have like, you know, a mini zigzag effect here, where this point to there, and there, all these are somewhat going to be what you call
Angles in the same segment.
Yeah, angles in the same segment, right? But it's also a cyclic quad. So you also want to remember that when you will need to prove a cyclic quad, you could also just look for angles that have like a zigzag effect that are equal to each other. So for example, here, this angle will be equal to that one. And then this angle here down here will be equal to like that one over there, you see. So that's for cyclic quads, but then there's a third thing also that's usually neglected, and that is that opposite angles of a cyclic quad add up to 180. So if you're looking at this angle here will be equal to that one over there. I mean, these two added up will equal to 180, you see. That's something else about cyclic quad. So anyways, with all this also being said, right?
Oh,
We need to keep
there's also that theorem that kind of confuses me. The one of area, speaking of proportionality. That area,
oh, it's more like the proof.
yes.
It's more like it's used for like the proof of the proportionality theorem, you see. Because with what you may call, with the proof of the proportionality theorem, you use you literally just make use of the normal area formula, half base times height. Because with the just like a rough sketch, right, of what you do during that, when you prove that theorem, you like, for example, work with something like this. You have this here, they'll draw this here, and then they'll like draw a right angle triangle. They'll draw like a line here also where this is 90, and then you draw another one there where this is 90, and then they'll start talking about, you know, half base. This will be like, they'll label this like K. So it's all like the proof of the theorem that deals with the area. It's not to say something to do with area is a theorem on its own. No, the area portion of things is only considered while proving whatever we'll be proving. It's not like a standalone theorem. You see, does that make sense?
Okay, yes.
Yeah. So let's see here. With the rest of what we are working on, right? You need to keep in mind that R, as mentioned already, is going to be for radiuses, you know, like the radius and all that. Meaning, if you look at this, you have certain theorems that should remind you of R. You see, like the angle at the center of a circle being double the one at the circumference. You see, you should always remember this by keeping in mind that these lines will always be equal because that's the radius. Secondly, you should also remember that as long as you have the radius, always look out for an isosceles triangle. because this is something that's like heavily neglected ever so often, you know. And then thirdly, you have the D there. I mean, lastly, I mean, what did I say thirdly for now? Lastly, you have the D there, which is supposed to remind you of the diameter of a circle. Because remember, the diameter of a circle will always subtend a 90-degree angle, you see. But then this is not like that accurate. Let me just redo that. You have a circle here, you have a diameter over there. That's what the D is supposed to do. It's supposed to remind you that you should remember the theorem that says an angle subtended by the diameter of a circle is equal to 90 degrees. So is that clear now?
Yes.
Yeah. So let's see. So with everything that's been said now, right? This is also to say when you're going to work on Euclidean geometry, you can remember this acronym because it will keep these things in your head. And then there's also one other acronym that I always try to keep in mind, and it's like TPEX. TPEX. If I write a TIPEX. Okay, this here should remind you of angles in a straight line, you see. Angles on a straight line. Remember, angles on a straight line, they add up to 180 degrees straight line. And then here you have P, right, which is exterior angle of a triangle equals to so this would be saying the exterior angle here is equal to the sum of the opposite interior angles. You see, exterior angle of a triangle equal to the sum of the opposite interior angles, you see. And then the X there is just there to remind you of vertical opposites, you see. So all these tools here, let's put your vertical opposites. So the idea with these two words here, Dr. Cape Town and TPEX, it's just there to tell you that when you're going to work with Euclidean geometry questions, in as much as we may want to remember our theorems, right? You don't want to limit it to that. You also want to remember that your things like angles on a straight line, you see, that also like is together. Like it should be in your head also, those basic things when you're going to be working with Euclidean geometry. So does that make sense?
Yes.
Perfect. So on your side, I'm assuming you probably want us to look at some Euclidean geometry questions, but then also on Amy's side, if you're still here, if you have any questions specifically, then now is the time to shine. You can send me those questions and we can look at one or two of them and then we can vamoose, you know, because we really don't, remember, we don't need to spend forever on the group session. All we need is to just come in, answer questions, and then be out. So let's do it. Let's do it.
Can't we do the last year's paper, like the questions of last year's paper, November?
Well, your best bet is maybe thinking of something specific that you for example have been like working on. If you can think of something specific, that would be better, because for example with if you're thinking of past papers and maybe even like last year's paper, you can always get that on the second channel, metric math past papers. Because with metric math past papers, that's where I basically like go through full papers from like start to finish, where for example if I go to like paper, you see here NSC 2021 maths paper 2 memo, and you can see the idea here is with all these memos, right, they have timestamps, meaning for example whatever you'll be working on, you can always like double check in the timestamps where that specific question is. For example, if I look at say now you're dealing with paper 1, right? And you want to work on I don't know, like let's say the sequences and series. You will know that, okay, these are the timestamps for you to go directly to question 3. And then say you want to look at the financial math part of that paper, then you know that you can just scroll down to question 8, click on a timestamp, and you will have this exact question that was there in the 2021 paper. So on your side, if you know that you were maybe working on something and you were struggling with that, we might as well go through that. Or we could also maybe look at an example from this study guide here that we legit just started like pushing. So with this study guide, I think you're gonna start seeing it here and there, depending on, you know, wherever you're gonna see it. So with this study guide, I think we could look what you may call at like the trigonometry, at the Euclidean geometry section for like examples, because the idea with this study guide also is that whatever you're going to be working on, it always goes to the basics first. Like here, if you see Euclidean geometry, right, it's going to go through like the revision and then, you know, proofs and everything. But then when you start with proportionality and all that, it's going to start with the basics of like ratio and proportion. So for example, page 267 here, let me see where if I can go there. So if I look at something like page 267, it's like the next page here. You can already see this is giving you your summary of like your theorems, and also obviously like, you know, the proofs and all that. But then if you look at when you start with like proportionality theorem and all that, let me just scroll down to where the proportionality theorem is. Similarity and proportion, or yeah, similarity and proportion. The first thing that's low-key like spoken about is like the basics of ratios, of which this is super important, because these are some of the basics that most people forget, and now work becomes difficult for them, you know. So I think in terms of a study guide, this is the one that I would definitely recommend. So I think in terms of us going through a question, we might as well even maybe pick out a question from this study guide and then see how that goes. Or we can just pick out any other question from like wherever else we can get it from. So on your side, yeah.
Where can I get that study guide?
Yeah, you can get it directly from us. I'll be able to maybe like send you the EFT details and more details of the study guide. And I see Amy sent a question on the group here. Perfect. So let me just do this. Yeah, so I'll send you the details of. Pardon?
I can't hear you properly.
Oh wait, how about now?
Oh.
Am I still not audible? Can you hear me now? Or is my network?
Yes.
Yeah, because you're also breaking a little bit. But let me maybe do this. Oh wait, Amy had some network issues there.